So we're here at ETH Denver with Michael Lewellen, who's head of solutions architecture at OpenZeppelin. So Michael, if you would mind introducing yourself, how you came to crypto, where it's taken you, and what you do at OpenZeppelin.
All right. Where I started with crypto, I started out actually spent a lot of my lunches in high school in the computer lab. And so eventually at one point I found out about Bitcoin mining, and apparently I could print money. So I started putting it on some of the computers, running it. This was back when you could actually do that and make something out of it. Now it's all big ASICs, but I made enough to realize, okay, I have apparently a few $100s of Bitcoin. What is that? What is money? Went down the whole rabbit hole and started going to local meetups in Dallas, Texas, where I grew up. And eventually I started to talk to enough people that needed help setting up a wallet, setting up their own miner, doing a lot of stuff. And I was always pretty technical as a kid, played with electronics, built my own computer. So I started helping people out, and pretty soon I became the only crypto consultant in the area that knew how to help people in person. So did that for several years, eventually got my computer science degree around the same time that Ethereum was taking off. And then I shifted into Solidity and smart contract development. Did a lot of work with different projects, both corporate and startups or DeFi. And then eventually found my way to OpenZeppelin about 3 years back to help manage security audits on their security team. And been there ever since. Made a recent shift to solutions architecture, which is more high level. Are you managing security end to end, not just your audits, but are you thinking about your design and threat model in the early development phase, and then after your audit, are you deploying it correctly? Are you monitoring? Do you have an instant response process in place? Are you prepared on the full spectrum of the development lifecycle? So that's currently my big focus, working with a team and enjoying working with a lot of big clients like Compound, Matter Labs, and other big projects in the space.
Yeah. So, well, OpenZeppelin is relatively unknown to non-technical crypto users, but your clients are some of the biggest companies in the space. So what makes you the go-to cybersecurity solution for crypto?
I think several things. First of all, smart contract library is very prolific. So even if we say that they're not clients, they're just using the free library, that's always a great starting point to talk to someone and say, well, if you want to get a security audit from someone, maybe go with the person who you've already trusted most of your code base to. So that's a great start. But I think on top of that, we've been in the industry for a long time, since like 2016. We've got a really good relationship where a lot of our developers or auditors go way back with a lot of other people in the industry. So we're a known quantity. We've developed these relationships with partners, and we've also been around long enough to get better at our operations, not just, hey, you come in for an audit, we figure out how to scope it, we book you, but saying, hey, we'll build retainer relationships so that you can have recurring time set aside with us on a regular basis. We'll be there to do extra advisory, extra monitoring, do things that other firms might not be able to do or not comfortable doing. And we're very involved in standards. So upgradable proxies is a standard that people from our team wrote. We have several other EIPs related to custom errors, related to ways of doing namespace in a more, basically namespace storage in a more configurable layout, and tons of other things. So our names pop up in a lot of places, people from our team, and it keeps people talking, and usually it's the sort of people you want to work with.
So based on that, what are the biggest threats that are facing crypto end users, and how do you help mitigate them?
There's a lot. I think some of the biggest threats are still some of the simplest, like mismanaging keys and access control. So that is just a education game of making sure they understand good practices, use multi-sig where possible, hardware wallets, etc. But then getting into the code itself, I think some of the biggest risks we have are the cascading effect of integrations. DeFi composability is really powerful, but it's also very dangerous if one of those Lego blocks changes or has a bug itself. That can have a ripple effect. We've done a lot of work with Compound, that's a lending protocol, but it integrates a lot of tokens, bringing collateral on chain, deploying to new chains, and that can introduce a lot of vulnerabilities. For example, we had one issue with TrueUSD where they had a double entry point in their contract, which meant you could call it from more than one source, which created integration issues with the protocol, not just with us, but with many others. And so patching that on-chain live is very difficult. Luckily, we worked with the TrueUSD team to get it fixed, and they were able to address it very well. But these are the tricky things. You can't just assume the token is secure today, but maybe in the future it could be upgraded, or a new change is introduced, or something. You have to basically you have to stay on your toes and recognize that smart contracts are not as immutable as they might have used to be or claimed to be. It's a shifting landscape, and you have to keep an eye on not just your code, but everyone else's code that you might use.
Okay. Can you tell us a little bit about just smart contract security in particular, and what the challenges are when the environment is changing so rapidly? How do smart contracts keep up with that when they're not really upgradable easily?
Yeah, it's still a new developing space, but there are some best practices and standards that people are becoming aware of. I would say programming in general, like usually when you're deploying something on a server, you have the ability to rapidly patch it, but with smart contracts, you usually don't have that ability. Usually you have a lot of funds at risks, and if you want to get out a fix, it might not be there in time to save funds, and sometimes all the funds might be stolen. So you almost have to treat it like you're building a plane. It's going to be up in the air. You're probably not going to have a chance to land it if something goes wrong. So you have to really think carefully about your quality control. And that comes down to designing to not just deal with a lot of the weird quirks that just come up with smart contracts, like gas fees, different interoperability, just having a generally more immature ecosystem than others might, although we are getting there. We've been around for a while, long enough. But then just also dealing with the fact that, most security focuses on protecting data, but here you have to protect funds, and it requires a very different mindset, and it's all public. So anyone can usually read the code and start looking for bugs, whereas for a lot of other systems, they can keep that data and that code behind closed doors, and usually you can only see outside of the box when you're trying to hack something for normal websites or servers, versus smart contracts is usually all there, and you have to feel really confident that there were no bugs, and know that someone could easily find a bug and exploit it almost at will if you're not careful. So I mean, the biggest difference is it's just a heightened level of scrutiny and security compared to what programmers might deal with in other stacks or other software environments.
Cool. Yeah, I like your airplane analogy there. On a related note, there's been a few exploits related to unlimited token approvals, and often you sign something and it says, okay, unlimited. Why am I signing unlimited USDC on this token? So what's your opinion on that? And do you feel like there's just a degree of laziness to implementation, or is it something that people just have to deal with? And what's the alternative?
It's one of those things where I think it's understandable, but I think it's mainly around UX. It's not a necessity. And I think for anyone that cares about security, unlimited approvals are a bad practice. That being said, it's one of those things where essentially what you're doing when you're giving unlimited approval is you're saying this smart contract can spend my money. If you trust the smart contract in the way it's written, maybe that's okay. It's a Uniswap pool, and you're like, Uniswap's trusted enough, the code's immutable, it'll never change, I'm fine with unlimited approval. But you have to remember, you're not just fine today, but months down the line if you haven't revoked that approval later. So it's down to the fact that, if I'm doing multiple trades on a swap, I have to do an approval every time, or I do one unlimited approval. So from a UX perspective, unlimited is easier, but I've given that blank check away, and I think what a lot of developers and users need to know is that's a blank check that you need to either revoke after you've done using it, or just really, really trust that smart contract. And I would say in general, you shouldn't have any hanging unlimited approvals unless you're like a daily user of that smart contract. You should just revoke it when you're done and move on. And if you have users that are not sophisticated enough to know the difference between an unlimited approval and a more specific one, then I think the default should be always just limit the approval to what you need for that transaction specifically, and definitely don't do it as a default. And if you allow unlimited, provide some information to the user to make them aware of the risks they take.
Cool. So a little bit of ETH Denver history. Back in 2018, ERC 721 was created here, the NFT standard, as a kind of a workshop that involved Demian, who's your co-founder, our co-founders, people from OpenSea, Figma, and so on. Did that have any, say, long-lasting effects on the culture at OpenZeppelin? Do you talk about this at your all-hands meetings? Does it come up? Do you know about it?
It does come up. Like sometimes when we talked about changes we're going to make to the, because we maintain the ERC, you're talking about 721? Yeah, we maintain that standard, and sometimes we'll put out new implementations, and sometimes Demi was like, oh yeah, that came up in the meeting, like things like how we would deal with numerability and a few others. So it does come up, but I feel like a lot of things in 2018, 2017 are still like have lasting effects. Like I remember the first DevCon 3, I think that was the same year roughly, if not right before. And it was like, that was when we first launched Ethernauts. Naturally, when 7.21 came out, we added that to the library. So there's a lot of things that are still part of our library, part of our stack, that we've been continuing that came from those couple of years, where the library, as well as the team at OpenZeppelin itself, really grow into their own. I mean, that was when the team was probably a dozen or two, maybe a little over a dozen, and this is before even my time. So I'm hearing this from storytelling. But now we're like nearly over 100 people at OpenZeppelin, so the team's grown massively, and so it's always good stories to hear for the people that have just joined to know like how things were done and how they can still be done, because sometimes just coming to these conferences and talking to people around here about things they're working on, you know, we try to do Zoom, we try to Telegram, chat, or talk in the forums, but it's really hard to sometimes really dig into cool, interesting ideas without just being in person and chatting and being in a casual environment. So glad to be back.
Yeah. On a related note, you were personally co-authoring something, well, it's a bit more modern than the 2018, but the ERC 7512, which is an attempt to bring smart contract audits on-chain. Now, can you tell me a bit about that initiative? What kind of challenges you're facing with it? Is it being adopted? What will it solve?
Yeah, it's something that was spearheaded by SAFE, and so they brought a lot of other security researchers, including myself, on as co-authors to kind of like review the spec, help to tweak it, and now it's in draft format. It's not yet, I would say, at a big adoption phase. There's still a lot of work that I think needs to be done to finalize it before we'd expect a lot of people to adopt it, but there has been work from a company called ZenGuard that's been working on providing it on-chain for safe modules, to have a registry of like, hey, these are modules that have been audited that should be safe, so you can recognize it on-chain. And I actually was at the EAS, Ethereum Attestation Service booth recently, and they're actually a core part of that stack, because you put a lot of data on-chain, you want to have like a clear standard to verify it, you don't want to reinvent the wheel. And in a lot of cases, you don't want to put like an entire audit report on-chain. That's like going to be expensive, but you can have ways to attest to all the critical information and then link to some off-chain source, which is what EAS provides. So the real trick is going to be, we do want auditors to use it, and we also are going to need auditors and general security firms to get more involved in the deployment process, because that's about, hey, this address has been audited, and in a lot of cases, audit reports don't focus on addresses, they focus on code. They're like, this source code in GitHub at this commit has been audited. Whether that's the same code that actually ended up getting deployed, sometimes is an open question, or at least it's not a very clear one. You might be able to like compare the Etherscan verified source code to what was in the audit report, but it's not a clear process. So the idea is not only would we, if we introduce this and it gets adopted among a lot of different audit firms, that not just changes the practice of how we verify or how we publish audits, but how much more involved we should get in the deployment process. And that's going to be a new thing for a lot of audit firms. So we're going to have to take our time and do it right, so that it's a very as seamless a process as it can for people to adopt it.
Do you have like a timeline that you're hoping for this to see like adoption on this?
Honestly, I would say it's still open-ended in terms of the end date, but I would say we are hoping to see some like actual audits published before the end of the year, and hopefully get the standard itself in a final call or finalized state within the next year, by probably 2025, if not sooner. I'd say that's a long-term goal. But yeah, really we put it out there, and now we've spent the last couple of months taking in feedback, and I think now the bull market's coming through, I'm hoping to see a little bit more traction, because we're going to see a lot more degenerate projects out there, and we're going to want to make sure that some of them are audited, and hopefully integrate with tools like ZenGuard and others that are actually going to show users, hey, do you want to use an audited contract or not? Create incentives for projects to want to have that attestation on chain. So we're going to kind of let the market take from there, but we'll see how it goes.
Okay, so just to close us off, what is something you wish people would understand, or do people misunderstand about OpenZeppelin? What do you think they wish they would know about OpenZeppelin?
I guess the one thing is, it's something that we've had for a couple of years, but we just did a re-release of one of our products, Defender. We put out a new 2.0 version. A lot of people don't know we have a product. Some people don't even know we do audits, actually. They know about our smart contract library, but then they're like, oh, you do audits? That's cool. And then some of them say, oh, you do audits, but I didn't know you did monitoring too. So in a sense, we do all, like really everything end to end that might be needed for security, but our security product Defender does a lot of things for monitoring, incident response, operations, and it's meant to be a tool that people can just pick up and use. We offer services on top to help create custom integrations or introduce best practices or just train people on how to do incident response and monitoring on their own. But the tool gives you a lot of initial things to start with. Even a code scanning tool called Code Inspector that tells you if there's bugs in your code. Doesn't replace an audit. We put that very clearly in front of the developers, but it is a really good way to like get an initial sense of how many bugs do I have in my code, fix them, and then go in for an audit, because then hopefully you'll have a better report in the end. So Defender is available. Anyone can sign up. So you just go to the website at openzeppelin.com, find Defender, and try it out. So I'd say we want as many people as possible to give it a go and let us know what they think and see how we can make it better.
Okay, so let's get the word out there. Thank you very much for joining me, Michael, and all the best with 7.5.12.
Thank you for having me.